All right, in assignment number 6, we're going to be continuing to talk about solving quadratics by factoring, but this time it's all quadratics. So yesterday they were in a nice form. They were in standard form to begin with. And today the equations that we're going to come up with are not going to look like they started out yesterday. They're not going to be in standard form. So we're going to have to put them in standard form and then solve them. So this is what I'm talking about. It looks like, boy, it looks like a mess here. But it's really not that much more difficult than what we did yesterday. We're just going to need to put this in standard form. And so I'm going to start to solve this equation by combining all of my x's and x squareds, maybe getting rid of the parentheses. I'm going to start by using the distributive property here. 3x times 5x, well, that's 15x squared. And then 3x times negative 4 is negative 12x. And that equals the 13x squared minus 11x plus 15. So then what I want to do is get everything on one side, so this equation is just equal to 0. So I think what I'm going to do is move everything on the left-hand side, everything over here, to the other side of the equation. So I'm going to start by subtracting 13x squared. If I do that, those are going to cancel out, but that means I'm going to have to subtract 13x squared from this side. 15x squared minus 13x squared is 2x squared. Then I'm going to add 11x to both sides. So these will cancel each other out, but then negative 12x plus 11x is negative x. And then I'm going to subtract 15 from both sides. So this cancels out, and I'll just subtract 15 from this side. So now it's equal to 0. So now it's very similar to the kind of questions that we did yesterday where we were factoring. And so I'm going to do the same thing here today. I'm going to solve this by factoring. I'm going to start with 2x times x because 2x times x is the only thing that gives me 2x squared. And I want something here and here that multiplies together to give me a negative 15. And I'm going to go with a negative 3 and a positive 5. And the reason I did that is because now I have a 5x as my inside terms. 2x times negative 3, that's negative 6x. And 5x and negative 6x does give me my negative x in the middle. So now if those are equal to 0, I'm going to have two equations, either the 2x plus 5 equals 0, or the x minus 3 equals 0. And so if I have the 2x plus 5, if I subtract 5 from both sides, I'll have 2x equals negative 5. Divide by 2, and x equals negative 5 halves. That's one of my solutions. And then here, if I add 3 to both sides, then I'm going to have x equals 3, and that's my other solution. I could check both of those to make sure that this side of the equation here equals this side of the equation here. And if I did that, I would see that both of those would be my solutions to the equation. So that's what our equations are going to look like. I'm going to have you look at this one. Try this one first on your own. Pause the video, see if you can do this on your own, and then restart the video to see if you got it right. Hopefully this is what you were able to do. The n plus 2 squared, that means we're going to take n plus 2 times itself, n plus 2, which means we're going to have to FOIL. I'm going to take n times n is n squared. N times 2 is 2n. 2 times n is another 2n, and 2 times 2 is 4. And that equals 6n plus 19. And so I have my n squared, but then 2n plus 2n is 4n. If I subtract 6n from both sides, I'll have negative 2n. And then if I subtract 19 from both sides, 4 minus 19 is negative 15. And now this will be equal to 0. And so then I'm going to factor this. I'll have n times n equals n squared. And if I have a negative 5 and a positive 3, that's going to multiply together to give me negative 15, but it's going to give me a middle term of negative 2n. So then either n minus 5 is 0 or n plus 3 is 0. And if I add 5 to both sides here, I'm going to have n equals 5. That's one solution. And if I subtract 3 from both sides on this side, n is going to equal negative 3, and that's my other solution. So there's two things that work when I plug them into these equations that are going to give me a correct answer. And that is n equals 5, and n equals -3. And so let's try one more. We want to find the dimensions of this rectangle if the area is 21. Well, to find the area of 21, we're going to take the length times the width. Well, that's W times W plus 4. That has to equal 21. So I'm going to solve this equation, but I'm going to solve it by first distributing that W. It's going to be W squared plus 4W. And then I'm going to subtract 21, so it's equal to 0. And now I'm going to solve this by factoring it. I'll have W times W equals W squared. And if I went -7 and a +3, no, let's switch that around. Let's go +7 and a -3. -3. That's going to end up giving me a +4W in the middle and a -21 on the outside here. So then either W plus 7 equals 0 or W minus 3 equals 0. And if I subtract 7 from both sides, the width is either going to be -7, or here if I add 3, the width is going to be 3. Now, even though this makes the equation true, it doesn't fit with our situation, because our width cannot be negative. And so our width is going to have to be +3. So that means this side is going to be 3. This side here is going to be 3 plus 4, which is 7. So it's a 3 by 7 rectangle. And that's what we're going to be doing on our homework assignment for today. We will go ahead and do those questions, and then we'll come back and go over questions that we have in class tomorrow.